So this one's also in terms of a double angle and a single angle, so we want an identity. Now cos 2 theta has those three different identities. You could start with cos theta plus theta, and you know you've got cos squared theta minus sine squared theta, but we don't, if we can try not to, is put two different, like a cos and a sine. So if we can put everything in terms of coses, since there's a cos theta on that side, let's do that. So we know another identity for cos 2 theta would be 2 cos squared theta's minus 1, and we'll make it equal to cos theta there. If we put everything on one side, I should have done that straight away, and in kind of order of a normal quadratic, so I'm thinking 2m squared minus m minus 1 equals 0. For some reason it's just easier to think of with m's, and I know they're both primes, the 2 and the 1, and I want a negative 2 plus 1 is negative 1, so that works nicely. So here we're going to have m being negative a half or 1. So that means my cos theta is going to be negative a half or 1. Alright, 1's probably easier to solve. So between 0 and 2 pi, there 0 and 2 pi is my theta for that one. So that's nice and easy. If I'm looking at negative a half, so you can see we're going to get two answers, and they're going to be in that, which makes sense from the graph as well, but you might want to do it this way. So we're going to get them in this quadrant and this quadrant here. So remembering this is the pi minus quadrant and this is the pi plus quadrant, and we want, so the acute angle for a half, so cos 60 being a half, 60 being pi on 3, so I want to, can I fit it in there? Do that. So I want to subtract pi on 3 and add pi on 3, so I'll make these, there we go. So 3 pi on 3 minus pi on 3 would be 2 pi on 3. 3 pi on 3 plus pi on 3 would be 4 pi on 3. Alright, so we're going to have four answers. We've got theta equaling 0, 2 pi on 3, 4 pi on 3, and 2 pi.